In today's video, we have 4 different simple functions that we will differentiate, and I labeled this one differentiation part 1 because I am doing a series of functions from 1 to part 4, and we are going to apply power rule here. That's why I selected these questions. So let's see what we have. So before we begin, if you haven't subscribed to this channel yet, please support this work by subscribing to the channel and click on the notification bell if you want more updates. Alright, so you can locate the video Intro to Differentiation, Introduction to Differentiation. This will help you to know the basic steps, the basic rules you need to know before you tackle any differential equation. Locate this in the playlist Differentiation, Functions and Integration Engineering Maths 1. So that is the name of the playlist. All these videos are there. Please look at that one because I have already explained the functions and how to differentiate them into details. So for this one, the first function, we have root of x. We have x to power 5 over 3, 1 over x squared, and 1 over cube root of x. So to begin with, the first thing we need to do is that because we don't have a variable that is equal to these functions, we need to name these functions using, let's use the variable y. So first we will say that let y be equal to root of x. Now from here, before I can differentiate, I need to change this term. Root of x is the same as x to power 1 out of 2. So this becomes y, giving us x to power 1 out of 2. Now, from differentiation, we can apply the power rule. The power rule says that if I have a function y giving me x to power n, I have already explained this in the introduction video like I said. You have to look at that one. Now, this is a function in terms of the variable x. So n here is an exponent. So the power rule says that if you want to differentiate this, we have derivative of y with respect to x as dy dx will give us, use the exponent to multiply the function, n times x, n, then reduce the exponent by 1. So this is the power rule, where n is an integer. It can be any positive or negative number. So for instance, if we have y equal to x squared, then this becomes dy dx, giving us 2x2 minus 1, which is the same as 2x. Do we get it? So this is what we call the power rule. So we apply it here. So we have half as our exponent. So dy out of dx will give us 1 out of 2, x to the power 1 out of 2, reduce the power by 1. Okay, I'm just showing this step. So this is giving us 1 out of 2, x to the power. Now when you subtract 1 from half, the result is negative 1 out of 2. All right, now you can leave your answer here, but because the question was given to us in this form, let's try to change it again. So we manipulate this using indices. So from indices, I can rewrite this by saying this is the same as 1 out of 2 x, 1 over x instead, to the power half. All right, so that I can remove this negative. Now this half is the same as a square root, and this becomes 1 out of 2, 1 over root of x, and the final thing is to use this to multiply. So 1 times 1 is giving us 1, this times the denominator, which is the same as 1 over 2 root of x. So therefore our dy and dx is this result. So do we get it? So when you get here, we just apply indices. But if you didn't really get what I did here, if I have something like 1 over x is the same as x negative 1, because when I change the fraction into a linear function, this is what I will get. So if I have 1 out of x to the power half, it is the same as x to the power negative half. So I just apply that one here, so I can leave my final answer in this form. So this is for solution number 1. So let's move on to question 2. So this is very simple. Taking the derivative of this, we have dy dx, giving us, now the power rule says that use the exponent to multiply. So we have 5 out of 3, then you raise to the same function 5 out of 3 minus 1. Remember, we are subtracting 1 from this result. You can punch this side on your calculator. 5 over 3 minus 1. What result do we have? We have 2 out of 3. So the y dx is giving us 5 over 3 x to the power 2 out of 3. Now from here we can reduce this function by applying indices again. Now watch very carefully what I'm going to do. So this is dy dx giving us 5 out of 3 x 1 out of 3 times 2. So what I did was that I want to change this into a cubic root. So I'll factorize the numerator out. So I'm showing work for you to understand, okay? So once you factorize the numerator out, we have 1 out of 3. This 1 out of 3 is the same as the cube root of what? X. Do you understand? So dy dx is now equal to 5 out of 3 cube root of x, and the number 2 will square the x. Okay, so that is it. You can rewrite this in this form as I have here. So you just put this in bracket. Okay, so let's move on to question number 3. So from question number 3, we have 1 over x squared. So from here, before we can use the power rule here or differentiate this side, we need to change this into a linear function. So I've already explained this. So y is the same as x to the power negative 2, because this is the same as 1 over x squared. Now we can apply the power rule by using this to multiply. So dy dx giving us minus 2 x minus 2, reduce the power by 1 minus 1. Okay, you don't need to be showing this. Now the y dx becomes negative 2 x to the power minus 3. Now we can rewrite this back in this form. So this is the same as 1 out of x cubed. So we have negative 2 1 over x to power 3. So now dy dx is giving us negative 2 times 1. Don't forget this is over 1. Okay, so this time this is giving us negative 2, and 1 times this is giving us what? X to power 3. And we can leave our final answer here. So finally, let's take the last example and we are done for this one. Now we have here y equal to 1 over cube root of x. Before you can do this, we still need to change this side into a linear function by applying indices. So this is the same as y giving us, now watch, this is cube root, which is the same as 1 out of 3. So we can have 1 over x to power 1 out of what? 3. Then we change it back to a linear function, giving us y equal to x to power negative 1 out of what? 3. Once I cross this to the other side, the sign changed to negative. Now we can apply power rule by differentiating this. So we have dy dx giving us negative 1 out of 3, x minus 1 out of 3, reduce the power by 1. Alright, so we have our dy dx giving us minus 1 out of 3, x to power what? Watch this. You can punch this on your calculator. This is giving us negative 4 over 3. So we have minus 4 over 3. Then again, I need to change the equation back into its original state. So I'm about to apply the same principle I used in the previous one. So watch very carefully. This is negative, so we can change this whole thing into a fraction to maintain a positive what? Exponent. So this is giving us negative 1 out of 3 multiplying 1 over x to power 4 over 3. Okay, so if we have 4 over 3, then I can factorize the numerator out like I told you, and I'll have a cube root. Okay, so this is the same as negative 1 out of 3 times 1 over, let me show that, x 1 out of 3 times 4. Okay, so from here we can now move to negative 1 out of 3 times 1 over cube root of x. This 4 is now here. Okay, now you don't need to show this step for the sake of explanation. So now this is giving us negative 1 times this and 3 times the denominator. So our final answer becomes dy dx giving us negative 1 all over 3 cube root of x to power 4, and you leave your final answer here. So this is how we apply the power rule. These are basic simple functions. There are different rules in differentiation. Once you go through these videos in the playlist, you come across a lot of them, different examples and how to differentiate them. This is Daniel. Thank you for joining me here, and see you in the next one.